Hi, my name is Justin Pounders. I'm the Director of Machine Learning at Prolego. I'd like to take a few minutes to talk to you about weak supervision. And why is weak supervision important? Why do I want to take a few minutes to talk to you about it? Imagine yourself in this situation. Imagine you're given 1,000 documents and you're asked to go through sentence by sentence and classify each sentence in each one of those documents as whether they should belong to a certain classification or not. So for example, imagine you're given legal documents and you need to go through sentence by sentence and identify whether each sentence in each one of those documents is exposing you to a certain risk or not. Well, this is the exact situation that we found ourselves in an engagement a few years ago. And weak supervision is ultimately the way we solve that problem. Now, this is a text classification problem. And so we know that transformers that came out a few years ago, they're very effective at doing the classification part. But those transformers have to be trained on label training data. And so the real issue is, where do you get label training data? In this situation, nobody had solved this problem before. There were no open source data sets with legal documents containing this precise classification that we can download and train a transformer model on. We have to create the label training data, and that's very hard. And this is often the most challenging part of a large NLP classification task. It's in, how do you get the label training data? You can imagine hiring a dozen interns and teaching them how to label documents. But even in that situation, how are you going to collect their annotations? And how do you train the interns? Weak supervision, in a way, takes that process of training interns and makes it programmatic. It makes it automatic. It makes something that you can do without interns, because you can train, or you can build software to basically replicate that process. So the idea behind weak supervision is, we have input, and an input in this case is a sentence from a document. Let's stick with that example for now. And we know that we want to take each one of these inputs, each one of these sentences, pass it through a transformer model to generate a prediction, whether that sentence should belong to class 1, 2, 3, or 4. But of course, we need a label to train the model on. We need some sort of ground truth. The idea behind weak supervision is, we're going to mimic the intern here and use some simple rules and codify those rules as a function programmatically. So for example, I'm going to write a Python function that says, if this sentence contains this phrase that a lawyer would look for when he's classifying these documents manually, let's take that sentence and give it a label 1. So for example, if we're talking about payment conditions, this label function might look for a sentence, right to increase payments, or right to decrease payments, or right to withhold payments. And if it finds that particular text in the sentence, it's going to give it a class label of 1. If it finds another variant of that language, maybe it gives it a class label of 2 or 3 or 4. The idea here, though, is that this is not very sophisticated. We're using language that, in this case, the lawyer was already looking for, and we're simply writing a simple lookup. If this sentence has that language, let's give it a label of 1, 2, 3, or 4, however it applies. Is this perfect? We'll give you perfect ground truth labels? Absolutely not. That's not the goal. What this function will do is, it will give us labels that are pretty good. It gives us labels that are approximate. And we can, in this situation, rely on the transformer to fill in the gaps. So if our label function, let's say, captures 80, 90% of the sentences and gives them the correct label, then the transformer, because it already knows about language, because it was pre-trained on a lot of English language documents, it can fill in the gaps. It can pick up the other kind of 10 to 15% of similar language that should be labeled, let's say, class 1, even though our label function didn't pick it up explicitly. So to try to say this more succinctly, we can take business expertise and codify that as a function to give us approximate labels, and rely on the transformer to be smart enough to pick up the other examples that were not explicitly identified by label functions. This is a huge time and cost saving, because this label function, it's a keyword lookup. It's very easy to write that. It's only a few lines of Python. So it turns out that this is the idea that we implemented for for the project I was just describing, and it worked very well. It was able to identify risky sentences in legal documents, even though we hadn't explicitly assigned those a label. There is other research and there's other existing libraries that implements a similar approach, actually the same approach. And this all falls under the idea of weak supervision. So I want to walk you through some more sophisticated elaborations of this idea. In this situation, we took all of our logic, all of the key phrases that we were looking for, and we bundled them into one big label function. Well, the problem is this gives you a hard assignment. So we have kind of noisy rules giving us a hard assignment. In this case, this must be class 1. Well, we need a more sophisticated approach um, to, we need a more sophisticated approach that will soften this. So we don't have very hard confidence in our noisy labels. So we can improve this situation by using a probabilistic model to tie together label functions to give us a label that represents our confidence in that label. So the first thing I'm going to do is take our label function that has all those rules, all those key phrases, and break them up into a couple of pieces. So maybe this first label function is looking for one particular phrase, right to increase payments. The next label function might be a slightly different phrase, right to withhold payments. Think of each one of these label functions as a piece of evidence that's indicating what the final label should be if we knew it. Of course, we don't. But we can take these pieces of evidence, we can take these label functions and tie them together using a probabilistic model that will say, you know, I'm not 100% sure that it should be class 1, but based on the evidence that I saw in the label functions, in the key phrases you told me to look for, I think it's an 80% chance it's class 1, 20% is class 4. This is what the library Snorkel does. And Snorkel is based on research that you can find online. I'll link to it at the end of the presentation and in the notes of this video. But it's a probabilistic model that says, given the evidence that I see, so in this case, the first label function thinks this sentence that came in the input should be class 1. The next label function thinks it should be class 2. And the last label function thinks this should actually be class 4. It disagrees, which is fine because these are noisy or approximate rules. Snorkel will build a probabilistic model to combine these pieces of evidence to give you an approximate label. This gives you a little bit more latitude when you're training the model because it's not saying that this, my noisy rule said this sentence must be class 1. It's softer. It says, well, I think it's 80% class 1, 20% class 4. This helps the training process. So as I said, this is a great way to quickly start applying weak supervision to your natural language processing or your natural language classification task. The library is very well documented. It's also very fast in building these probabilistic models. And it's worth noting that even though I'm showing this probabilistic model that combines the label functions as a little circle here, it's actually pretty complex. And if you go back and read the papers, there's a lot of deep thinking and sort of sophistication that has to happen to get this to correctly and intelligently combine these pieces of evidence. But the great thing about Snorkel is they did all the hard work for you. So you can simply download the library, it's open source, and you can immediately apply it to your classification problem. But now I'd like to take another step past Snorkel for a few minutes because there's been some recent research in this area that I think is very compelling and very exciting. Recently, there's been a paper called Deep Probabilistic Logic that's come out, and this idea is still weak supervision. It's still weak supervision, and it looks a lot like the model that Snorkel implements, but there's a few changes. One is what I've denoted here as the red arrow. We still have our label functions, which takes we still have our label functions, and those label functions still get combined into a probabilistic model. But here, we're going to create an extra step that takes what the model thinks, so in other words, the model prediction, and folds that in as an extra piece of evidence. Why is this significant? Well, our label functions, yeah, they're noisy, yeah, they're imprecise, but we've already mentioned that the transformer, because it knows a lot about language, it can be pretty good at identifying inputs that should receive a certain label just because it knows about language. So in other words, even if our label functions didn't pick up a certain clause as being risky, our model might see language in that example and say, hey, even though this wasn't labeled, the language, the wording in this sentence is very similar to what was labeled. So I'm going to go ahead and give it a, let's say, a class 1 label. I'm going to go ahead and put it in the class that lines up with my label functions. So we're able to use the generalizability of the transformer model because it knows language quite well, and we can incorporate that as an extra piece of evidence. And what this will allow you to do is sort of pick up false positives. So in other words, if I see a sentence and my label functions did not label that sentence as being risky, but the model did, I would initially think that, well, maybe that's a false positive because my model is saying it's positive, it's risky, even though the label functions did not. In actuality, what the model might be telling you is that even though your approximate labels didn't label this as risky, I know enough about language to know this is actually risky. And so we can view the prediction of the model as an extra piece of evidence that goes into this probabilistic model that gives you labels. Now, at this point, this becomes an iterative process. You start with just your label functions, train a model, but then during that training process, the model is going to become smarter. It's going to learn how to pick up some extra examples, and that evidence, those predictions, can inform the next iteration, the next training cycle, to pick up more and more class labels based on what it's learning. So I think this is a pretty significant step in generalizing the idea of weak supervision. There's one last workflow I want to show, and this is very recent. It just came out in December of last year, so December of 2020, and it really solves a couple of pain points that we have experienced personally. One thing I haven't mentioned so far is, how do you, over time, improve label functions? So on the first pass, let's say that we sit down, we talk to a lawyer, we identify the key phrases that he's looking for in the legal documents we're trying to classify. We turn those key phrases, we turn that language into label functions. And after we train the model, we see that the model, yeah, it's working pretty good, but we have questions as we're going through the error analysis. So let's take this sentence. Our label functions did not flag it as being a risky sentence, but the model did. Well, is the model right in picking up a sentence that should be classified that our label functions missed? Or is it a true false positive? And is it something that we shouldn't be labeling at all? So we have to take those examples and go back to the lawyer to have the lawyer look at them and to tell him and to tell us whether we were correct, whether the model was correct, or whether we need to refine the label functions and get smarter at our rules in assigning labels. This can be a tedious process. And we have to go through this process of having the domain expert review our results because, remember, there's no ground truth here. We never know exactly whether we're right or not. We use the evidence in the functions and the predictions from the model to try to classify to the best of to the best of the model's ability, but we still have to have a human set of, we still have to have the expert look at the predictions at the end of the day to tell us whether this makes sense or not. Maybe we need to go back and adjust our label functions. So the paper that came out at the end of last year that I'm excited about solves some of these pain points explicitly. It does two things in particular that help shorten that iterative process where we have to go back and forth with the expert to understand how well our model is performing. The first thing it can do is automatically identify new label functions. So in other words, as the model is learning to predict classifications on sentences, it can look at its internal structure and propose new candidate label functions. So modern transformers are built around the idea of self-attention. And what that means is that it can look at the words that are contributing to classification and identify which words, in a sense, are important to making that classification. This information can be used to identify new label functions, new evidence. So again, using this example, let's say that I'm looking for right to increase payment, right to decrease payment, or right to withhold payment. As the model is learning, the attention mechanisms inside, maybe they are putting a lot of attention on words like guaranteed payments. Well, I can do some introspection and see that because those phrases, because those words are receiving a lot of attention inside the model, maybe they should be surfaced as a new piece of evidence. That's what this new work, which is called S4 or self-supervised self-supervision, proposes. Using the model and using what the model knows internally to automatically provide new label functions, to automatically propose new pieces of evidence that iteratively makes the trading process more resilient and more robust. This shortens the amount of time, it reduces the amount of times that we need to go back to the domain expert to say, well, hey, we need more language, we need more examples, we need you to help us fix our label functions, because we can use the internals of the transformer model to expedite that discovery process of what should be in our label functions. That's the first component that makes this process easier. The next component is active learning. Because as I've already mentioned, we don't have 100% confidence in the predictions that the model is producing because we don't know ground truth, because we don't have gold labels. And so when a model makes a prediction, so when a model gives us a set of predictions, we'll always go back to the domain expert to have him or her look over our predictions to tell us whether we're on the right track or not, to tell us whether our predictions are making sense or not. Now, if we include active learning, which this paper S4 or self-supervised self-supervision did, active learning is an automatic way to identify the samples that are most in need of human review. The active learning will identify the samples, the sentences from all of our inputs that most need a second look. And the way it does this is simply by looking at the confidence in the prediction. And the confidence in the prediction, if it's, in this case, 80-20, this means that, well, we're 80% confident that this particular input should be class 1. And let's call that a pretty confident input. If we look at another sentence, though, and the prediction is maybe 25% across the board, that would indicate very low confidence. We don't really know how to assign a label to this particular input. And so active learning is a method that will automatically identify those low confidence predictions and surface them so that so active learning is a method that will identify those low confidence predictions so we can take those inputs to the domain expert and make the most of his or her time. In other words, we're taking the inputs that we're the most uncertain about to get explicit input from the expert on. And we can have confidence. So this is what self-supervised self-supervision proposes. And I think it has a lot of promise at shortening the overall time to take a model from the initial assignment of label functions all the way through to production, because it can automatically identify new potential label functions, as well as servicing the specific inputs that are most in need of feedback from the business, from the domain experts. So to wrap up, that's weak supervision in 3 steps. The pros of weak supervision in general is that it avoids us having to hand label large sets of documents, which is often the most challenging part of a natural language classification task. It also allows us to leverage domain expertise explicitly. So in this case, I'm not a lawyer, but I can go to a lawyer and he or she can tell me what they are looking for as it pertains to this classification task. And I can take that knowledge and explicitly codify it through label functions, which are programmatic functions that then will assign approximate labels to my entire corpus of documents. Now, those labels will be approximate. They won't pick up everything, but they pair really well with transformers, because transformers already understand language to a pretty sophisticated degree. They can identify synonymous terms and they can assign correct labels even if my approximate label functions missed it in the first pass. With some of the new research that's coming out, we're seeing extended capabilities as well. We can see we can have models that, for example, automatically discover new language that should be included in a label function. This can be done somewhat automatically. We're also seeing with S4 or self-supervised self-supervision, the ability to incorporate active learning into the process so that we can take the samples of input that need feedback from the expert that we have not much confidence in our labels, and we can take those samples back explicitly for human review and possibly human annotation. So what we're seeing in the new research is the ability to shorten the overall cycle of going back and forth with the business as we try to improve our label functions. So I'm very excited about weak supervision and the direction it's taking in research right now, because on the one hand, it allows us to quickly annotate a large set of documents. We can take those noisy labels, combine them with transformers and the generalizability of transformers, and get very good results, even though we're using imprecise labels. With the more recent research, we're also seeing that we don't have to go back and forth with the business as much, because early on when we were using weak supervision, that was one of the kind of pain points. We would construct a set of label functions, we would generate predictions, but then we'd have to take all those predictions, we have to try to pick some samples that we think are meaningful that we take back to the business to get feedback on. They tell us if we were right, if we were wrong, and then we have to take that feedback and somehow go back and modify our label functions. Especially with the new work that we're seeing in S4 methodology, which I will link to in the next slide, we're seeing that we can automate that process because we can automatically identify candidate label functions directly from the transformer. And we can also use active learning to identify the subset of sentences that are most in need of feedback from the business, that most need a human set of eyes on them. So that's why I'm excited about weak supervision. There are potentially a couple of downsides. On the one hand, so that's why I'm excited about weak supervision. Now, there are potentially a couple of downsides. The trivial, okay, last time. So that's why I'm very excited about weak supervision. There are potentially a couple of downsides. Now, as I mentioned a bit ago, this little model that combines all of your label functions, that combines all the evidence to assign the approximate label, that's actually a pretty sophisticated model. It's based on probabilistic factor graphs, and there's a non-trivial implementation to get that right. Now, fortunately, if you use a tool like Snorkel, they've done a great job of implementing a model that will tie all of your evidence, tie all of your label functions into one probabilistic label. Is very well documented and very easy to use. And so I would recommend that as the place to start. It's a great library. Another potential downside is we still have to decide up front how to form our initial set of label functions. We still have to go talk to the domain experts and try to tease what we should be looking for and codify those as label functions. If our label functions don't have good coverage, so let's say that there's a subset of samples that we're just never classifying because we don't have good label functions, well, the model is not going to be smart enough to pick up everything. It's not going to be smart enough to fix all of our mistakes. So we need to have pretty good label functions to begin with. So those two potential downsides aside, I'm still very excited about weak supervision. We've used weak supervision successfully for a couple of projects. And as I've said a dozen times now, it is a tremendous time saver because we don't have to have human annotators labeling large amounts of text data. It works perfectly with transformers because transformers have already learned a lot of language in their pre-training, and we're able to work directly with domain experts and take what they know and codify them explicitly to produce approximate labels. So I hope that's helpful. If you've used weak supervision on some of your projects, I'd love to hear from you, and I'd love to hear how this works for you. Here are the links that I promised. The first link is the link to the newest piece of research that I've read, which is S4, or self-supervised self-supervision. The next one, DPL, that's deep probabilistic logic, which was the predecessor work to S4. Finally, there's Snorkel and data programming. This is the paper, the research paper that library is based on. It's interesting, although a pretty tough paper, I would say, to get through in terms of how they build the model. But if you want to jump straight to the code, you can go to Snorkel's website. As I said, the documentation is great. The library is very easy to use. And this is absolutely where I would start with if you're looking at weak supervision for the first time. To really get into the guts of how those models combine the pieces of evidence, how they combine the label functions into a probabilistic labels, it requires a pretty deep dive into probabilistic modeling. So there's a couple of books that I've listed here if you really want to get into the weeds in understanding how these different pieces of research use mathematics to build those models. So I hope that's helpful. Thank you for your time. We'll see you next time.